Today I'm going to show you how to make pure hydrogen out of simple chemicals like sodium hydroxide and aluminum. Now here are my equations. I'm going to do 1 mole of aluminum and have an excess of sodium hydroxide, which is 1.125 moles. And with that, I'm expecting to get 118 grams of sodium aluminate and then 3 grams of hydrogen, which should be about 33.6 liters. The first step is to measure out the aluminum. I already measured out 27 grams of aluminum. Next step is for me to measure out the sodium hydroxide. And now I'm going to need 45 grams of sodium hydroxide. Once you've measured your sodium hydroxide, I recommend putting on gloves for this next step. The next step is to get an ice bath, like this one right here. This will limit the amount of steam that's going to be generated, as adding sodium hydroxide into water is an exothermic reactant, and also reacting it with aluminum. And we don't want steam contaminating our hydrogen. So fill up your beaker with about 200 to 250 milliliters of water. Now, with a glass rod or spoon, slowly start adding the sodium hydroxide. As I've said before, make sure to add the sodium hydroxide nice and slow, as you don't want the excess heat to produce steam. Now that your sodium hydroxide has fully diluted into the solution, add the solution into an Erlenmeyer flask with a 24 sized nozzle. Now put your Erlenmeyer flask into the ice bath. Now that it's cold as possible, get a balloon and stretch it out. After stretching out your balloon, put your first sample of aluminum into the Erlenmeyer flask and then quickly put the balloon over it. This reaction might be slow, but that's because it's cold. But this slow reaction will give you cleaner hydrogen. Here's a closer look into the reaction. You can see the bubbling happening. And once it gets really white, I recommend you to swirl it around, clear it. As I said before, this reaction is really exothermic, and the water might boil even with the ice bath. But if that happens, don't panic, simply remove the balloon and let the reaction complete all the way. The solution should become darker and darker, and that's the sodium aluminate forming. As you see here, I noticed the reaction started to boil, so I quickly removed the balloon and let the reaction continue without touching it. As the reaction continued, you can see more and more vapor and steam was coming out. Most of it was just water, but there was still hydrogen in it. I would recommend collecting it, as it would contaminate your hydrogen. And as you see, the balloon floats, showing that it's pure hydrogen. As you can tell, as I said before, this down here might be half steam, half water, half hydrogen. This is pure hydrogen. As the exothermic reaction continued, it started releasing a lot of heat, and the water started boiling, which started making a positive feedback loop. This balloon I took off right before that happened, and flies up. Oh God. Now, what I can do to prove this is hydrogen is, first of all, if I let go, it should go up. So this is hydrogen. More like 90%, because if there would be a little steam, it would still weigh it down. Hydrogen is a lot lighter than helium, so that should give you a higher pitched voice. So if I bite down, take a small breath, don't do this at home as well, don't do this at home, it should give me a higher breath.
Is my voice higher? Oh yeah, you see? That's pure hydrogen making my voice a lot higher. My voice can stay high like this, but I need to take deep breaths because it might displace my oxygen. The more deep breaths I take, the more my voice should come back to normal. The more my voice comes back to normal, the more I know the less of it left. As always, thank you for watching my videos. If you enjoyed it, make sure to like and follow. Join my Patreon and my Discord.